Hello everyone, today our group members are going to introduce the stimulating stock price model for you. With the growth of economy, investors pay increasing attention to the prediction of stock price. Excel as a helpful tool for financial analysis can play a useful role in estimating stock price. We will discuss the procedure of developing a stimulation project, which will use the input value of parameters to estimate the future stock price. In addition, we will refer to the geometric Brownian motion, which is a continuous period predicting process. It is indicated that geometric Brownian motion can be used to predict the stock price because it can be applied to everywhere. Moreover, we use the VBA function in Excel to develop the stimulation project because it is a good function using the code to perform the predicting process and show the results in a worksheet with specific graph and charts for the investors to understand. Therefore, we will first discuss the geometric Brownian motion and its effect, and then we will explain the process of developing stock price stimulation model in Excel, which includes initial setting, variables defining, setting up data input area, drawing stimulated stock price, drawing a chart of stimulating stock price, and adding extra feature and format output sheet. Finally, we will analyze the outcome and lead to the conclusion as well as some limitations. Now let's move on to Ying Chen to introduce the geometric Brownian motion model.
Simulation stock price as to estimate future stock price use geometrical Brownian motion model. First, we introduce proportion return. Price change divided by current price equals mu multiplied time interval plus sigma multiplied uplift multiplied squared time interval, among which mu means expected rate of return for data t period. Data t is extremely small period. Uplift is interval allowed deviation from zero mean of standard normal distribution. Sigma is standard deviation of expected price return. Then, develop a formulation to log value of expected return. Log value of future stock price plus delta t divided by current stock price, among which log value of expected return of log normal distribution, whose value ranged from 0 to very large unlimited value. Coupon equals mu minus half of sigma 0.2 is the expected continuously compound return rate. Finally, we will use the st plus delta t equals st multiplied uplift of coupon multiplied delta t plus sigma multiplied uplift multiplied square delta t. As our final formulation in data application use VBA function. Next, let's pass to Yueyue to talk about the VBA code.
Now let me introduce how we create this model. So first, we set up Excel to work with VBA. It's simple. We just go to the options and create a developer. After that, we can create a model in Visual Basic. And then we do the initial and automatic setting. So first, we create this project with the formatting as this picture showing, and we give the value 0 to each of the cell. After that, we create this code to clear all the content, which including the data and the charts. We don't want them to influence the operating of this project before we start. And then we use message box because we want to, once we open the module, the Excel will automatically present a message box with welcome meeting. Then we can set up a data input area. So first we set up the input area of each variables and give value to each of them. And then we want to manage the data input into reasonable range. If the variables the user's input are out of reasonable range, we want the Excel automatically present a message box for alarming or stopping the operation, because technically all the variables should not be negative in order to get the meaningful result. So we choose if, then, and if structure to set the minimal value of variables so that it can give notice and exit sub if the data is out of range. After that, we create this code to determine the start row of the data in order to clear any graph of worksheet and any data will occur before we start the program. Okay, now let's move on to the next step.
After setting initial values, our group developed stock price simulation based on geometric Brownian motion model. We use the formula derived from this model and apply it for each next structure as shown in this format. Then we need to list all simulated data on the output area, thus the above objects are given to their related cells. At last, we redefine the variable pod and code for the purpose of generating a series of related output. Following the simulated stock price, a chart is required for showing clear trends of forecast future prices, certain components, and uncertain components. Initially, we determine the height, width, and proper location of the chart. Then the output area of the last step is chosen to be an input area of the chart, and the scatter line is selected as the chart type. Offset chart title and orchis title are added and all necessary lines are removed. Consequently, the final chart will display in this way. At the end of the program, we adjust range objects to add extra feature and format output sheet for the worksheet. At first, the range that needs to manipulate is selected by function range.select. In order to activate the application, ActiveCell.formula R1C1 is used to add labels and variable items in different cells. Then we define the front board of the title cells to be true respectively. Also, a proper size of column A cells is set for a purpose of clear vision. For formatting output sheet, current stock price is set as a dollar format and the expected return and volatility are set as a percentage format. So the following figure shows the outcome of the above setting. So next, let's pass on Yanan to introduce the outcome and the finding.
The procedure of users running this module is quite simple. You just need to input all the variables in arrow B4 to B8 and then click the Start button. Here is an example of how the outcomes look like. It is easy to observe in the chart that as two components of stock price, certain components determines the overall trend of future stock price, while uncertain components causes continuing fluctuation. Furthermore, we set other variables constant and change value of volatility as 20%, 30%, and 50%. As volatility value increase, the simulation stock price path is likely to cover larger change range and more fluctuating at the same period. In a word, stock price will increase and decrease more sharply as volatility increasing. At last, we point out two limitations. One is that in this model, users are required to provide specific value of parameters. However, it is actually hard for ordinary investors to estimate these parameters through limited data resources. Therefore, the module has limited effects on practical individual investments. Secondly, the module is only applied to short-term simulation of stock price. The longer time interval we consider, the more variable a stock price will be. In a conclusion, we achieved the aim of developing a simulation project to predict future stock price. We use the Excel with VBA function and come to the findings that the certain component determines the overall trend of future stock price as linear, while uncertain component will lead to continuing fluctuation on future stock price, which is also related to the Brownian motion model. Moreover, The change of stock price will be sharper if volatility increasing. Therefore, this price stimulation model can be a useful tool for investors by inputting some variables and getting the change of future stock price. So this is our presentation. Thanks for watching this video.